this video, I'm going to be specifically making it this video for M104 at IUK. This is going to focus on the topics that are in section 3-1 part A. Alright, the whole entire section deals with introducing a system of linear equations, and in this video it's going to specifically involve solving by graphing. Alright, now just to lay out conceptually what's this going to look like and how this is all going to work, your three possible solutions. We've got all this written out ahead of time. I will work three examples out after I do this explanation. When you graph two lines, you basically have only three ways that the lines can fall. The first way would be if you graph the first line and then you graph the second line and they end up crossing at one point, then you are going to have exactly one solution. Alright, this is often called a consistent system. Alright, another scenario that could happen when you go to graph the lines, you graph the first line, you graph the second line, and they end up being parallel to each other. Alright, in which case, because they do not cross, you do not have a solution, so this is a no solution. It is also commonly referred to as an inconsistent system. The last scenario would be if you graph the first line, which would say be the red line, and then you graph the second line, which is the blue line that lands right on top of the first line. Alright, then that means every point, the intersection of all of those two lines being on top of each other, there are infinitely many points on a line, there are infinitely many points where they are crossing. So our solution is infinitely many solutions, and we often write that as IMS. Okay, but the whole point is when you graph that system, where do they cross? If it crosses in one point, you have one solution. If it doesn't cross at all, you have no solutions. And if they are on top of each other, those two lines are touching in infinitely many points, so you have infinitely many solutions. Alright, now let's take a look at working three of these examples out. Alright, in this first scenario, I've got y equals 2x minus 2, y equals negative 5x plus 5. Alright, I have intentionally color-coded this so that it'll be easier when we look at the graphs and see the graphs. Each one of these are in slope-intercept form. Alright, so hopefully at this point in the course you are good at graphing things in slope-intercept form. So for the red line, I'm going to graph first. The negative 2 is my y-intercept, so I'm going to come down to negative 2 and put my first dot. Alright, then I have a slope of 2, or 2 over 1, it's positive slope, so I'm going to rise 2 and go to the right 1. I'm going to rise 2, go to the right 1. Rise 2, go to the right 1. Do this multiple times. You're very consistent there on where this line is going to be placed. Alright, at the same time I can go the other way by going to the left 1 and down 2. Continues that pattern of finding that slope. Alright, and then hopefully you have a ruler. I think I even have a ruler here. Let's dig a ruler out. I do have a ruler. Okay, so I'm going to go ahead and connect using a ruler. Alright, now first line is drawn. Now I'm going to draw the second line. Okay, again it is in slope-intercept form. So y-intercept of 5, 1, 2, 3, 4, 5. And I'm going to run a slope of negative 5, which basically means I can go down and to the right. Alright, I can go up and to the left, either one. So let's go down to the right first. So 1, 2, 3, 4, 5, and to the right 1. Alright, now that one lands on the red line, so technically I wouldn't need to continue to run that slope again because I found the point at which they intersect at. Let's go ahead and connect those roughly there. Okay, so clearly we have our solution right there. Alright, let's add that. So I'll point to it. It is at the solution, and it is a point on our graph. That point is 1, 0. The solution to a system of equations must be written as an ordered pair. That's crucial. When you write your system to an ordered pair, it has to be written as an ordered pair. Okay. Alright, so there's the first one. Alright, now let's do the second one here. Alright, these are in standard form. Okay, for the students that have been in my class, we do formulas for finding the x and y intercepts. So I'm going to go ahead and do that method here. Okay, we use our standard form as ax plus by equals c. Alright, I generally do not have my students solve for y and put it in slope-intercept form. Normally what we do is we have memorized that our x-intercept is the formula c over a, and we know that the y-intercept is the formula c over b. Okay, we also use this and find slope. Our slope formula for this standard form is negative a over b. So my students are used to seeing that. If you've never seen that, I'm sure you can find one of my other videos somewhere on my channel that I go into great detail about teaching that. Okay, so what I would do with this is I would, on the red line, I would find my x and y intercepts and use those 2 points to graph the equation. So x-intercept for the red line is going to be c over a, which is going to be 3 over 3, which is 1. And y-intercept, let's go over here, y-intercept of the red line, okay, is going to be c over b, which is going to be 3 over 1, which is 3. Okay, so let's get a piece of graph paper here. I'm going to go ahead and lay it on top of this graph since we've already done that graph. Alright, so I know for my red line I have an x-intercept of 1 and a y-intercept of 3. So then I'm going to put that on. X-intercept of 1, y-intercept of 3, 1, 2, 3. And then I'm going to go ahead and draw that line because technically all I need is 2 points on the line to be able to draw it. Okay, if I wanted to be more accurate, I could run that slope since now I know what that slope is. Okay, now I'm going to do the exact same thing for the purple line there. I'm going to find my x-intercept. I'm going to use my formula of c over a, so c over a. So this is going to be 12 over 6, or 2. Y-intercept, I'm going to use my formula of c over b. Alright, c over b, so 12 over 2, which is going to give me a 6. Alright, then I'm going to come over and I'm going to graph those. My x-intercept is 2, so 1, 2. Y-intercept is 6. 1, 2, 3, 4, 5, 6. I've got my 2 points, and I can, let's make sure I put that in the right spot. 1, 2, 3, 4, 5, 6, I did. Okay, and I'm going to then connect those to make my line. Again, if I needed more points, I could have. I did a pretty bad job of drawing those. Alright, but we can see here these two are going to be parallel. Alright, if the 2 lines turn out to be parallel, then I have a no solution for this one, because they did not intersect at any point. Alright, and then just going back and referring to that other word that I used, this would be an inconsistent system. Okay, so far we've done one of each kind. Alright. In this last example, we're going to be taking a look at an equation in slope-intercept form and an equation in standard form. Alright, so let's begin by graphing the line that is in slope-intercept form. I'm going to go ahead and start with the y-intercept at 3, so 1, 2, 3. And then I'm going to run a slope of 2/3, so up 2 to the right 3, up 2 to the right 3. Let's go the other way, to the left 3, down 2, to the left 3, 1, 2, 3, down 2. Okay, that should be enough points, and we're going to be able to connect our line. Okay, now we're going to take a look at the line in standard form. Again, I'm going to use my shortcut formulas. I'm going to start with my x-intercept, and that formula is c over a, which is a negative 9 over 2, which gives me a negative 4 1/2. Alright, now because that did not come out to be an integer, it's not going to work nice to be able to graph because it would be a rough estimate here. So I'm not going to use that value. Even though I've calculated it, I can now see that's not going to work. So I'm going to go with my x-intercept, which is c over b, and that gives me a negative 9 over a negative 3, which gives me a y-intercept of 3. Now, since I need 2 points on a line, I'm going to go ahead and use the formula for slope, which is negative a over b. My a is 2, so that's a negative 2 over b, which is a negative 3, which gives me a positive 2/3 for my slope. Okay, and when we graph that line, we're going to see the y-intercept is 3, and then the slope of 2/3 up 2 and to the right 3 puts this line exactly on top of the first line. So this is the case where when you graph the 2 lines, they are on top of each other. So that means that this one has infinitely many solutions. Okay, so infinitely many solutions. And shortcut. Okay, if you're doing this by hand, then I usually accept IMS as a shortcut for that infinitely many solutions. Definitely thanks for watching. If the videos are helping, don't forget to share with your friends so they can benefit too. And don't forget to subscribe to the channel. Thanks.